Welcome to Joe, who's joining us because I did the principles course with me in person. So good to see you, Joe, even though I can't actually see you or hear you, but you can type in, or you can put up your hand if you want to have a chat to us and we can unmute you. We can't turn your camera on though, so don't worry about that. You can, we've done a good bit there in these first three modules to get everybody on the same page. And now it's about just arming you with the final tools that you need to do your safe system assessment. So it's really important that we did spend that time getting our head around the principles, the categorization of things into exposure, likelihood, and severity, because those are critical aspects of undertaking a safe system assessment. So what we're going to do today is really go through the mechanics of how to write up a safe system assessment, what you should be looking at, where you put different categorizations, how to do the scoring, and a few other things. So I've got some slides as per usual to tick us along. And at the end of this module, what I'll be doing is walking you through your assignment, which you have to do at the end of this. And your actual module 5 is all about you undertaking this mock safe system assessment. So I call it a mock safe system assessment because we've sliced off quite a number of components of a safe system assessment that are quite time consuming and I suppose aren't adding a huge amount of value in the training purposes of a safe system assessment. So they certainly add value in the full safe system assessment process, but I'll get into that a bit more. But you know, we didn't want you to have to spend a good few days working on your assignment. We wanted to, you know, hone it down to a couple of hours and give you, you know, just an assignment around that. So as per usual, I've got a few slides. I'll be asking you a few questions. So by the end of this module, we're hoping that you can source the guidelines for safe system assessment. So if there's anything that you haven't got your head around, you can read the guidelines as well. So I'll point you at those. How to complete the safe system assessment matrix, which is the meat of a safe system assessment. And you're all fairly primed up for that, having gone through that assignment previously and categorizing things into exposure, likelihood, and severity. Write a safe system assessment report. So going through what would be included in that report or what is sort of the industry standard on a road safety, a safe system assessment report, and then categorizing treatments into these primary and supporting categories. And that's going to be a challenging task to get your head around for some people, but I'm going to point you at some little tricks and tips to help you do that, and some documentation by Austroads is helping us along with that quite well. Now for Joe, that's what Wally looks like. So just make sure you count as every time you see that pop up on the slides. That's going to be one of your quiz questions at the end of this module. So just a recap of where we've got to in these modules. We really unpack that safe system philosophy just to make sure we were all on the same page. We talked about the different elements of the safe system, and we talked about how a safe system assessment does a little bit of a delve into those. All those elements, the vehicles, the people, the speeds, the roads, the roadsides, and even the post-crash care, which isn't represented in this particular diagram, but there's a bit of thinking about how you would go about extracting any injured parties or getting to them as quickly as possible in crashes. The principles we talked about, human bodies are vulnerable. There's only so much force we can take. And I'll come back to that because that's so important to our safe system assessment. People make mistakes. So we're assuming crashes happen. We're not encouraging that, and we're trying to minimize the number of crashes that happen. But we are in the space of acknowledging we're dealing with humans who are fallible, and these issues will happen. And we need to manage the energy associated with those. And we have this shared responsibility. So we've got to acknowledge that we have a responsibility to create this environment that is for humans, and humans being a fallible creature that we are. So they are the principles again. We are aiming at that no death or serious injury. It's an aspiration, and there is a lot of advantage to a safe system assessment because it gives you that scoring between 0 and 448, which I'll show you shortly, and the project ends up sitting in that spectrum somewhere. And so that really aligns with that terminology that I keep using, which is aligns well with safe system principles or doesn't align so well with safe system principles, rather than that is safe system or that is not safe system. Because you'll see when we get to it that nothing really pops out at full safe system, which would be actually incidentally a score of 0 out of 448. And in my hundreds of safe system assessments that myself and my team have done, we've never scored anything 0 as the whole project, that is. We sort of redefined risk under this safe system context to be the multiplication of exposure times likelihood times severity. So in most other industries in the world, that exposure is embedded in the likelihood factor. So it's usually just likelihood times severity, or probability times consequence, depending on the language you want to use. But here in the safe system assessment world, it's exposure times likelihood times severity. Now, those who are monitoring the Austroads releases, you would have probably noticed the recent release of the Austroads Guide to Road Design Part 6, which is roadside safety, barriers, and the like. And that has also this exposure, likelihood, and severity, but a slightly different lens on it, just to make our lives extra complicated. So while we align definitely with this exposure, likelihood, and severity in those two documents, the assessment framework and Part 6 of the Guide to Road Design, there's slight variances on especially what is deemed exposure. So just be aware of that if you are working with both those documents. Now, I asked this as a quiz question at the start, one that I was confident on the answer of, unlike the helmet law one. But we got a lot of answers coming there, and I'm sure you were just writing it as quickly as you could, and that's the reason why quite a number of you went off slightly onto different speeds. But it's important that you calibrate your understanding of force and death chance for these different crash types, because when we come to assessing the severity of the crash that you've predicted in the safe system assessment, you need to be referring back to these and factoring this into your thinking. So we'll just run through this again, and you'll see here that the green line here is that passenger vehicle striking a pedestrian. And I talked about that the 10% chance that strike at that speed will be fatal to the pedestrian. And that there is at that 30 km/h mark. Really important number in terms of speed for the safe system and safe system assessment. 30 km/h or below is where we see sort of low likelihood of death and serious injuries are coming down very, very quickly under that speed. Above that, very severe, very quickly. 50 km/h is the side impact, right angle crash between passenger vehicles. Now, in your safe system assessment, you're going to make kinetic energy management judgments, and you go, oh, well, it's not exactly right angle, but it's pretty close, so I'm just going to generally think about things with this curve in mind, and the speed, it's probably going to happen around 60 or 70 km/h. Well, oh my gosh, we know we're in a high chance of death and certainly high chance of severe injury as well. And then head-on crash, we have that 70 kilometers per hour as the point where things exponentially start to kick up and severity becomes high. So really we need to remember those numbers. Okay. 30, 50, 70, so critical to safe system thinking. We get a little, we delved into a little bit more detail on that. So we were talking about right angle crashes being that 90-degree crash, but if we can alter that crash angle a bit and get a bit of, vectors where our energy goes out into the environment a bit when these two vehicles collide, we can up the speed a bit to around the 60 when those sorts of exponential increases in the death rate and the high level serious injury rate pops up. And we see down here, one that scares me all the time, side impact with poles around the 30 to 40 kilometers per hour, but that is a side impact with a pole. One of the things I do talk to people a lot about, because they're in an urban environment, for example, a 50 kilometer per hour environment, and there's power poles very close to the road, and they say, well, but you've just told me that the side impact with pole is around the 30 to 40 kilometer per hour mark, is when it gets real, it starts to get really bad. So I'm going to rate this as runoff road severity being very, very high. I'll say, well, actually, in that speed environment, the ability to actually yaw the vehicle, which is yawing is to get the vehicle going on a side. So, essentially get the back end of the vehicle out. So the vehicle is sliding sideways into the pole, which is what we have as a side impact. It's very hard to do that at those speeds, or it's unlikely that that's going to happen. And most of the crashes in those urban environments with power poles are more frontal impacts, where we have much more energy absorption capability with the pole because of the airbags, the crumple zones, the seat belts, and all of that working in your favor. So this is actual impact speed. So what we often see is that a vehicle will leave the road in these higher speed environments, start to yaw because the driver is trying to get back on the road, sliding, washing off a bit of speed, and then side impacting with poles and trees. In the lower speed environment, there isn't that sort of time to get that yawing and sliding, and there isn't the space to do that. So we see, to a degree, more frontal impacts. Pedestrians and cyclists, sort of in the 20 to 30 kilometer per hour kicking up. We showed that from the graph before. So when you come in your safe system assessment to analysing the severity of crashes, I want you to be referring to these. And I think I'm going to provide you, if I haven't done already, with a bit of a mock-up that we're doing. We're getting some peer reviewing of this done at the moment, but it's a good start. And it's a little heat map spectrum to show you scoring, to just help calibrate your thinking in terms of scoring of these severity outcomes. So Kathy, can you make a note of that, please, that we're going to send out that as a bit of supplementary help.
Sure thing. Can you take a quick question at this point?
Yeah, absolutely.
So the assessment should consider likelihood of various crash angles versus various speeds for any crash?
Yes, so I will show that. That will be explained in much more detail when we get to the matrix, and I think that will clear up in your mind as I show you that. So let me get through the matrix, and if that question is still valid, if it hasn't been answered, I'll come back to it and go into more detail.
Terrific, thank you.
So I've put lots of different ways to look at this crash energy and impact speeds, and I'm talking about crash energy, but it's really the speed that we're talking about, speeds and angles, really. Speeds, angles, and vulnerability of road users. Okay, let's jump into it. How do we actually do this safe system assessment? We're all now on this great platform of understanding the safe system, understanding biomechanical tolerances of humans, understanding a good bit about likelihood, exposure, how to categorize these things. Now we've got lots of pieces of this puzzle. How do we put it all together into this assessment? But before that, quiz time. I think it's quiz time. Depends if we've got a quiz sitting in the polls there. Oh my gosh, look at that. Now, Joe, this is not, you're not being marked on this. This is just a little interactive thing. And this one's certainly not being marked on because it's just trying for me to get a gauge of if you've had any involvement with safe system assessments. And your options there are nothing. Safe system, what now? I've heard of them, but not much more. I've had one done on my project. I've done one and I live, breathe and eat safe system assessment. So if you can't see the poll, those were the questions, and don't get too concerned, but maybe you could write into the chat or the Q&A, whatever you can see. You know, have you had any involvement in this thing of safe system assessments? And that'll just help me to understand the level that the group is at.
Thanks, everyone. I'll just close that one off now.
Beautiful. Let's share those results. Thank you. So, okay, the majority of you have heard of this term of safe system assessments, but don't know much more, and that's fine. And we're going to go through that in a lot of detail. 3 of you have had them done on your project, so that's good. You've seen them come in, and a couple of you have done them, so that's awesome. I will be, I think, clarifying a few little things within those people who have done them, and just making sure that you are doing things the same way that industry has decided is the appropriate way to do things at the moment. But this is excellent. Good, thank you. Now, stop me at any point, Kathy, as I keep ticking along. And we'll have good opportunity also at the end to answer questions about your task and how you go about it. But this is the origins of the Safe System Assessment, the Austroads document, Safe System Assessment Framework. It's a document that is available on Austroads' website. It's also in your memory stick and on Schoology. You should be having a look at it. It's got some good information in there, some things that'll help you. That came out in 2016, and so I was on the working group for that document. I wasn't one of the authors of it, but I was certainly on the working group. And I had been doing safe system audits before that, we termed them. So for a number of years before that, had been doing this thing called a safe system audit, which was trying to replicate a road safety audit, but with enhanced focus on severity and other elements of the safe system and a few other variances. And the reason for that was because all these projects were demanding to understand whether their project was safe system or not. And I was sort of saying, well, it's a spectrum. That's I'll give you a report that will sort of help to paint a bit of a picture for you. And a lot of that stuff got incorporated into this document. There were some things that Western Australia was doing in some different, slightly different lenses on things, and it got combined together, and this document was produced. Then it's been used for a few years, and there's been some things identified in there that could probably be improved a bit after, there's lots of these assessments that have been undertaken. So some of the jurisdictions have got together and now produced their own guidelines, which are based off that Austroads guideline, but help to clarify some of those areas that were not clear or don't really work in practice once you're actually out there in lots of different road scenarios doing these assessments. So the Victorian guidelines have, well, there's actually been 2 versions of those. So Victoria is very progressive in terms of ensuring that the best guidance is out there and available, and most jurisdictions are really sort of following the Victorian guidelines as a way to do these. Certainly DIPTI, the South Australians, are using their guidelines, but if you actually open up their guidelines, you happen to discover that they're exactly the same as the Victorian guidelines, just with a different front cover and a global replace of VicRoads with DIPTI. And a nice acknowledgement to VicRoads in the inside of the front cover. So basically these two documents are the same. And that's kind of good, I think, for industry practice, that we've been consistent, at least in 2 jurisdictions, the only 2 jurisdictions with guidance on this. And it is all based on the Austroads, Safe System Assessment Framework, just clarifying those specifics. Now, what we've discovered is, even with the VicRoads document, there's always these little bits and pieces that pop up that aren't clear, or that there's ambiguity. And so we've been working with the Department of Transport in Victoria to produce these fact sheets as an interim stopgap while they look to do another update of their guidelines and encourage Austroads to do a version, I suppose, 2 of the Safe System Assessment Framework. So we've provided you with those, and I really encourage you to have a flick through them. We tried to make them nice and visually appealing so you can see them, but they should help to clarify in your mind a few of these tricky issues. So, Kathy, any questions at this stage that I should be addressing, or do I keep ploughing on?
Just an update. DIPTI is Department of Infrastructure and Transport, so it's just DIT now.
Wow. Okay.
There you go. Just an update for you.
They
have to update their front cover now too, don't they?
They do. Department of Infrastructure and Transport.
Mm-hmm. Yeah. DIT.
Okay. All right.
That's DIT. Anyway, any other questions?
And
please
as a result of that, they've had to lock South Australia down for a while everybody gets their head around it.
Oh, that's harsh.
That was harsh. No, the South
Easy for us
Australians.
to say.
That's right. The South Australians will be right. A week of lockdown. We did 180 days of it, so you'll be right with a week. Trust me. Yeah. Okay. What I'm doing now is I'm popping up the end product before I even start, and it's a bit of an odd way to do it. But I like to be able to see what's the meat of the production, what's coming out of the end of this machine of a safe system assessment. And really, something like this is the output that most people are looking for. There is a lot more to it than this as an output, but this is really what we're finding that the project directors or the exec directors or the regional directors or the managers are looking for when they get these safe system assessments. They want to open it up and they want a quick snapshot of how well this project aligns with safe system principles. And what you can see here is that each of these clusters of bars is a crash type: run-off road, head-on, intersection, other, pedestrian, cyclist, motorcyclists. And what we've got here is some sort of score, and 0 is the best. The lower the bar is, the better the alignment with safe system principles. So what we can immediately see here is that the red here is the existing conditions. I'm not like this hypothetical project here, but what this hypothetical project is some intersection, and they have got an option to do a roundabout, or to do a traffic signals in a modified T arrangement, or do a traffic signals with a standard T arrangement. So there's 3 options on the table. And what we're doing in this safe system assessment is giving the project team a score sheet on how each of those options align with safe system principles and comparing it to what's currently there now. So the red is the current conditions. The orange is the roundabout, The blue is the modified T traffic signals, and the grey is the standard T traffic signals. And so you can see immediately there that we're getting improvements in a lot of the areas. Motorcyclists seem not to be getting much benefit at all from any of these, which is interesting. We see there, though, that cyclists are actually going the wrong way on this one, which is the roundabout. We're seeing a lot of, I suppose, improvement in everything. And you can get a total score, or you can break it up this way. I'll come back to that after I show you how you go through and get to that end, but that's the output. But the first thing you do in a safe system assessment is understand the context of the project that you're working on, that you're going to assess. And the Austroads document and the different guidelines from Department of Transport in Victoria and DIT in South Australia, they give you these prompt questions. They're not the only questions you'd want to be asking, but they are sort of the standard set of questions to get an understanding of the context and the scope of the project that you're about to go and assess. Asking these questions like, what's the reason for the project? What's the function of the roads? What's the speed environment? What road users are present? What are the sort of traffic flows? What's any movement in place categorization? Do you have any traffic modeling? Where are the local schools? And what are the desire lines for pedestrians? What I'll often do is, for when I'm doing a safe system assessment, so the team and I I'll have a look at what they send us initially, and then what I do is send them these prompt questions and either say, can you please answer these questions and send it back to us, or say, here are some prompt questions. We'd like to have a meeting with you. And these are the questions we're going to ask you. We want to understand your project. We want to really get a good platform before we start to jump in and do assessments. So why are we doing this? Well, it's not actually going to change the scoring of the assessment. It's not going to change how well things align or don't align. But what it will change is the recommendations that we make for any alterations. I suppose it may help us with the scoring in terms of vehicle volumes or pedestrian volumes or cyclist volumes. But apart from that, it's just understanding what is a meaningful recommendation. And this is the matrix. This is the meat of most safe system assessments for infrastructure projects. When you do a safe system assessment of a whole, like, remote community or a mine site or something like that, this is, I suppose, one component of the whole thing. But for our infrastructure projects, this tends to be the meat of it and the most where you spend your time. So you'll see here that, as I showed in that graph, the columns are all crash types: runoff road, head-on crash, intersection crash. Now, those three are for passenger vehicles, heavy vehicles, for vehicles, motorized vehicles. I shouldn't say motorized because motorcycles have their own category. Those are for passenger vehicles and heavy vehicles. Other crash type is anything that's been missed in any of these other categories, and I'll come back to it. Pedestrian, any crashes where the pedestrian is the one that gets the most severe injury. So that could be a car running off the road and hitting a pedestrian. So in your mind, that is not then a run-off road crash, it's a pedestrian crash, unless the vehicle is to run off the road and hit the pedestrian, but also a pole or something, and so that the occupant of the vehicle is severely injured as well, then it would be run-off road and pedestrian. Same thing with cyclists. Even if a cyclist is struck at an intersection, that is a cyclist. That goes in our cyclist category. And motorcyclists the same. So these three categories are really road user involvement in that crash. And these are the crash type, with the road user being the passenger vehicles or heavy vehicles. Other crash types give you some freedom if there's something you believe that's an issue that's been missed. And maybe that's like a crash with a tram or a level crossing crash. Maybe that's a sideswipe crash. Maybe you're very concerned with crashes with animals, or maybe rear ends at mid-block locations. So a rear end crash at a set of traffic signals would be categorized in the intersection category. However, a mid-block pedestrian operated signal or something like that, or a wombat crossing or the like, the rear end then would be in the other category. So you need to sort of make that judgment call. So they're the columns. The rows, and hopefully this is no surprise to you, are exposure, likelihood, and severity. So finally, it's, you know, coming together as to why I've been banging on about exposure, likelihood, and severity so much through the last 3 modules, and why you did an assignment on categorizing things into exposure, into likelihood, and into severity. Now in here, these are just a few little prompt things to show you how you would be thinking about it. Really though, the way you get to these scores, you know, you're thinking about the volume basically in these ones, AADT. These ones, you're thinking about all those likelihood factors, so things like the geometry, the speed, shoulders, delineation, and all of those sorts of things. And down here, we're into the severity factors, which are speed, angle of crash, the proportion of heavy vehicles. Obviously, if you have a high proportion of heavy vehicles, it's highly likely it's going to be more severe if the crash happens. But how do we actually convert that thinking to a score is the question. Like, we need a score now. Well, you are given this reference sheet for scoring, and it has scores from 0 to 4. And I'm going to go through a few of these just so it's clear in your mind how you arrive at this. So let's start with a 1 here. So in road user exposure, so that's this one. We're looking at exposure here. We want to put a score between 0 and 4. And so we have a look at our scoring reference sheet. And a 1 says here, for runoff road, head-on or other crash types, AADT is less than 1,000 vehicles a day. So there we go. We've got a pretty clear-cut indication of how we get to that score. You're going to likely have traffic volume. And for your assignments, we've given you some sort of fabricated traffic volumes. So don't get too concerned if you don't quite believe it. It's about just us ensuring that you know AADT is this, score is this. And the exposure one is pretty clear-cut for passenger vehicles, assuming you have traffic counts of some description. It's also pretty clear-cut for cyclists, pedestrians, and motorcyclists if you happen to have counts. Now, I suppose says a lot about our industry that for most safe system assessments, we get extremely detailed traffic volume counts, and we get nothing for cyclists, pedestrians, or motorcyclists in terms of counts. So we have to make a bit of an educated guess at it, a bit of professional judgment on that, and to decide that. But the guidance on that is pedestrian, cyclist, and motorcyclist crash volumes, the volumes that are subject to potential crash are 1 would be less than 10. Let's go and have a look at what a 2 is. Well, a 2 is for these passenger vehicle ones between 1,000 and 5,000 vehicles a day. And for pedestrian, cyclists, and motorcyclists between 10 and 50. And it goes all the way up there to a 4 being more than 10,000 for your vehicle volumes and more than 100. So some of you might say, well, you know, working in different areas, more than 10,000, that's actually not huge volume. But other areas will say, wow, that is really big volume. So those are the ones that are being used at the moment. There's a bit of work being done to look at, can we get some better guidance on this? Can we alter those? But for now, that's what it is. And you go about looking at your road or in the proposal, looking at in saying, right, the traffic volume is 4,000 vehicles a day AADT. And it looks like there's very low pedestrian volume walking along the road or crossing the road. There's very low cyclist volumes. In fact, we don't predict, you know, we predict it would be very rare that would be a cyclist here. And motorcyclists, we think, are 1% of AADT, which is a pretty good rule of thumb on motorcyclists. So then you go, right, well, where does that sit? Okay, well, I said 4,000 AADT, that's between 1,000 and 5,000, so that's a 2. I said very low pedestrian volume. We're thinking maybe it's just, you know, just sort of under 10. There's hardly anybody there ever, so let's go with a 1 for pedestrians. Cyclists, we said about the same, so we'll go 1 for cyclists. And motorcyclists, we said, what did we say, 1%, so 400. So we're probably in a 4 then for motorcyclists. Then you go to your crash likelihood. Now this, oh, sorry, I should cover off the 0. The 0 is that there's no exposure to a certain crash type. That might mean there is no side flow, no intersection, no cyclists, no pedestrians, no motorcyclists. Now, this one is, you know, is fairly clear cut. If you are doing a safe system assessment on a mid-block section, so there's no intersections, maybe there's some driveways or something, but there's no intersections, then your exposure to intersection crashes is 0 because there is no intersection. There is no exposure to that crash type. If you are doing something like a motorway and you're looking at cyclists and they're banned on this motorway and they're not there, you'd put a 0 for cyclists. Now, if you're worried, maybe you go, but I do remember that time that Dutch tourist arrived from the airport and then rode their bike down the motorway and through the tunnel and the like. Now those, very rare, very, very rare frequent exposures like that, I tend to not put them into the scoring, but I make a separate note of it in a later part of the safe system assessment because I don't want it to cloud that exposure score. But things like pedestrians, certainly on motorways, I always would have some sort of score in there, probably a 1 usually because of broken down vehicles. We do know that there's a lot of motorway pedestrian activity. I mean, relative, there's not a lot, but there is some with broken down vehicles, with taxis pulling over with intoxicated pedestrians and them getting out and I don't know what they're doing, throwing up or whatever they're doing. But we do see surprising amount of, I suppose, pedestrian style activity on some of these motorways. So that's why I factor that in. So then we go to crash likelihood, right? And this is where things get a little bit subjective. So let's have a look at a 1 for crash likelihood. It is highly unlikely that a given crash type will occur. That's not much info, is it? Let's go up to a 3. It is likely that a given crash type will occur. Well, we're really not getting a whole lot of help from these, are we? We get a little bit of assistance. Okay, let's have a look at a 4, because a 4 gives us a bit more info, doesn't it? The likelihood of individual road use error leading to a crash given the infrastructure in place is high. High approach speeds to a sharp curve, priority movement control, filtering across several lanes of opposing traffic at high speeds. So the one thing that we have provided in terms of one of those fact sheets is more information about that likelihood, but it's fairly simple. And the thing is that it is a relative likelihood across the network. So the reality is that the likelihood of crash at any individual location is extremely rare at a collective level. But if you do it at a relative level, sorry, at a collective or an individual level, but if you do it at a relative space, then it's easier to understand. So you're looking for those infrastructure features that you know increase the chance of a crash. And this is where like road safety auditors, experienced road safety auditors just shine. They're so calibrated in their thinking of what increases the score of a likelihood, what decreases it. And, you know, we'll be able to look at areas and intersections or designs and say, well, there's a, you know, this is going to be, there'll be a see-through effect here, or the curve here will have an adverse crossfall, which is going to significantly increase the likelihood of a runoff road crash. And that's then moving them up to higher and higher scores for these sorts of things. So you need to start, saying what factors in this road environment or the one they're going to produce are going to make that score go up or go down. Now, it would be very, very rare that you would ever put a 0 in crash likelihood. There is only minimal chance that a crash type will occur for an individual road user given the infrastructure in place. Only extreme behavior, substantial vehicle failure could lead to a crash. This may mean, for example, that two streams of traffic don't cross each other at grade. So you'd probably put that more into your exposure in terms of if you have grade separation, maybe thinking a little bit about the tie-in points and on-ramp and the like. But generally, you've got to factor in that we're dealing with humans and the actual humans. So not if everybody follows the rules, then the likelihood is 0. No, you have to say, this is what is going to happen out there. There's going to be people who are going to fall asleep, going to be intoxicated. So there's still this likelihood of some level. It might be really low considering all the infrastructure that's come into play, but it's likely to still be there. Then you go to severity. Now, severity is this sort of combination where we've got some really good data, and that's those graphs that I showed and the speeds and that information. And you then need to make a little bit of professional judgment, and there's a bit of subjectivity in it as well. But let's go for we'll have a look at what a 1 says here. Should a crash occur, it is highly likely that it will result, it is highly unlikely that it will result in fatality or serious injury to any road user involved. Kinetic energies are fairly low during the crash, or the majority are effectively dissipated before reaching the road user. So the meaning of that last little bit is like a road safety barrier. So the speeds might be high, but we know that it's going to be dissipated along as we wash off kinetic energy over time, and it's not going to reach the passenger or the driver of that vehicle. So that's what they mean by that. So it could still be high speed, but it's got to be managed. The energy has to be managed. We go up to the 4. Should a crash occur, it is highly likely that it will result in fatality or serious injury for any road user involved. Kinetic energies are high enough to cause fatal and serious injury, and it's unlikely that the forces will be dissipated before they reach the road user. And you make some judgment call in between all of this. And you base that on those graphs and some more information that we're going to provide you to try and help you calibrate this. So you take all of that and you put it into the matrix. But it's not as easy as just putting a score in each of those boxes. You have to justify your score. And so there is wording that goes into each of the cells of your matrix. And this is an example of one, and I'm going to sort of walk you through this. I don't expect you to really be able to read too much of that, This is actually one we've provided in your notes as a full safe system assessment, so you can see how it's sort of written up. Safe system assessments are a broad brush tool though, okay? We're putting some pretty precise numbers to things, but it is still a fairly broad brush tool, and don't lose sight of that. But what we do have is this big advantage of numbers to things. I'll pause there before I walk through this matrix in a bit more detail and show you how the scores actually get multiplied and how you end with if this score. But I'll just pause to see if anybody has any questions or clarification required at this point. Kathy, anything that I need to deal with?
Yes, please. Thank you. Okay, there was a question earlier about Metro Count now providing motorcycle information. I thought they introduced a new category a few years ago. That's from New South Wales.
Yes, there is the ability to count motorcycles. So if you get that data, that's wonderful. I know some projects are often using data that's a little bit old or something doesn't have that categorization, or other forms of counts that don't have that. So if you have that, wonderful. You're onto an easy answer to your exposure for motorcycles.
Great.
I have another point on that. I'll come back to it. Yep.
Okay. Doesn't the Austro Safe System Assessment Framework ask to have the absolute safe system option treatment with the minimal risk?
I'm not sure I quite understand that.
Yep. Might ask for some further clarification on referring to the final score chart.
Oh, okay. Sorry, I think I know what this person's talking about. Let me go back. The final score chart. Now don't count that Wally twice, by the way, because I'm going back 3 slides.
There were only options A, B, or C.
Yeah. Okay. So the process guidance on it. So what I understand this person is asking is why haven't, so we've assessed these and we've said, here are some recommendations that we have on each of these. Why aren't we seeing one that has this, very low or 0, because if they've taken on all of our wonderful recommendations, we've got this lovely low score here. So the reason that is, it's not really specified like that in the Austroads document, and certainly if it is alluded to in there, the Victorian and South Australian guidance really is a process where you provide your options or your recommendations, and it's over to the project team. Now, if you are to, they're doing an intersection upgrade to some local streets, and you were to go in and sort of say, well, a fully separated bicycle facility around this and raised pedestrian crossing, wombat crossings as well on each leg will give you your greatest safe system outcome. But you'll have to buy all the houses on each corner, or that's what they discover. They'll have to do that, and they can't do that. And so, providing that score would be helpful in one sense because it showed them what could be achieved, but they may end up saying, well, actually, we can't do that. And we're going to do this instead. We're going to take your second option, which was speed cushions on the approach and these specific crossing points. So what actually happens in practice is that you provide all these recommendations, and it's not just one recommendation. You provide almost a hierarchy of things that could be done. And they hopefully pick the one that aligns absolutely best. Then they could, if they want, as an option, say, this is what we've changed it to, send that back to you. And that is when you would add in that final score. So that the chosen option and all the modifications to it has brought everything down to this final score. So that's how it would close out. And potentially the person who's written that has seen that done in the past where they get that final output score. I think, yeah, hopefully that answers that question.
Thanks, Ken. What defines the road is very long in score 4?
Yeah, so that's exposure in score 4. So so the way that that has played out in industry is that if you have a very long road, well, any time the volume was to significantly change, you actually would start a new matrix instead of trying to sort of understand this from that long exposure perspective. So that's probably one of the things there's better guidance in the jurisdictional guidelines, and we've provided a specific fact sheet on this because for simplicity and consistency and the way it works in practice, we're able to just use the AADT and not be worried so much on that length. So,
Yep. Terrific, thank you, Ken. Just some comment about metro counts and capturing it's capturing pedestrian and cyclist volume, which is difficult. Eng's just reported that there are some new CCTV technologies that enable this, but it is rather expensive in comparison to metro count.
Yes. Yeah, I agree with that. There's certainly a lot more happening in that space, and a lot of I suppose there are some cheaper ways, I think, to do it, but yeah, it can be a bit of an expensive exercise. But the reality is, for this broad brush assessment, utilising your judgment is a fairly, I mean, it works for the broad brush nature of this to a degree. Obviously, if you get those numbers, bonus, and you can chuck them in. Okay, so let's delve into this matrix a little bit more, and again, lots of words on here, but I'm just using this. I'm not to talk you through the individual aspects of it, to show you how it all works. You'll see here the exposure scores we're putting. So the runoff road AADT is between 5,000 and 10,000 vehicles per day, which is the Austroads trigger. Simple as that, 3. That's what it is. So got some traffic volumes, it sits somewhere in that. Often people will write actually what the volume is if they had the specific count, but it's there it is. And you'll see that there it's a 3 there, a 3 there, being runoff road and head on. The intersection in this case is also a 3. Sometimes the intersection is higher because you actually add the mainline volume with the side road volume. It's an addition. Now, this one is actually playing out in a couple of working group committees with different departments to try to get some sort of agreement on it. But for now, we're all working on the addition of those 2. Again, a fact sheet's been provided. So if you have 4,000 on the main drag, but you have another 2,000, it ticks it up into that 3 category, as opposed to 2, which would have been just the 4,000, the main line. Other, well, again, you've worked out what your crash type is. It's most likely going to be the same as these as well. So you can see there, these all got the same, they all got a 3. Pedestrian volumes are unknown. Okay, for the purpose of this assessment, pedestrian volumes are assumed to be between 50 and 100. So there you go, acknowledgement. Didn't have counts. Not part of our safe system assessment to sit out there for a week and count pedestrians. We've made a judgment call from what we've seen while we've been out there and what we know of the area, and there you go, it's a 3. Cyclists, same. You might factor in there, is it on the principal bike network, strategic cycling corridor or the like, and motorcyclists, again, for this one, unknown, assumed to be between 10 and 50. So get a 3 as well. So there you go. This one happened to get 3 across the board for exposure. So you'll vary that as you need. The likelihood. This is the part that I really want to highlight in this one example. Factors that increase the risk, factors that decrease the risk. and you dot point these out. Things that make you want to make that score go higher, or things that make you want to make that score go lower. So, they increase the risk. Could be high speeds, could be sharp curves, could be the fact there's no shoulders, the line marking's faded, there's edge drop-offs, whatever you want to, put in there, whatever you see on site or whatever you're noticing in, this is for the existing conditions. And then some things that decrease that score. Well, that's got 3.5 meter lanes, it's got advisory speeds, it's got street lighting, and whatever else you can put in there. And then you make your call on what number to put. Now this one's interesting because it's gone with a 0.5, 2.5. Now the guidance is not to go to decimal places, but if you must, you can go to 0.5. The broad brush nature of this assessment tool means that we don't want going to multiple decimal places. And this was certainly one thing in the working group that I sort of said, yeah, we're going to give a numeric tool to engineers and technical people. They're going to run this to an inch of its life in terms of numbers. And certainly in the early stages, we did see that with people putting, to a couple of decimal places on the scoring. There's some really important benefits for not going to very, very intricate pinpoint numbers. And the reason for that is not necessarily this first score, but it's to show what actual impact any alterations would have. And if the impacts are minuscule, the safe system assessment just doesn't, it says you're not going to get us meaningfully closer to alignment with safe system principles. We're not, increasing your line marking a little bit wider isn't going to actually change your score. And that's probably a good thing for these early stages of projects where we like to do these assessments, because people, are often getting caught up in these very intricate likelihood changes in terms of road safety, where we need some major step changes often. And you've got this inherent risk sitting there, but you're trying to tweak around the edges to try to make it a little bit better. But no, we need to actually address some of these inherent risks. But this one has gone to a 0.5, and I dare say that's because their team couldn't decide between a 2 and a 3, and there was differences of opinion, and then they settled on that, the assessment team. And then the severity. Again, just like the likelihood, you write, here are a whole lot of things that increase the severity. Maybe the speed, the heavy vehicles, the rigid power poles, or the like. And things that decrease, anything that might decrease that down. Again, it could be the speed, it could be barrier systems, it could be anything absorbing the energy. And then you put a score there. And then you multiply exposure by likelihood, by severity, to get your score for runoff road crashes out of 64. So this one's got 15, the multiplication of those. And you do that for each of them. You get your score on each of these. And then you add across the bottom here. You add those up, and it gives you a score. This one's come out at 118.5 out of 448 for this intersection that is being looked at. Now for that one, this is the intersection that was being looked at. We're not going to analyze this in excruciating detail because it's just being used as the example to help you through this, but it's sort of on the approaches to a town. It's a giveaway controlled intersection at the moment. You can see a bit of it there. It's got some street lighting. It's got a bit of a culvert near there and the like. And these are the options that have been put forward. And this is actually probably perfect to do a safe system assessment, because you've got a bit of detail. You don't have the full, drainage plan, pavement plan, the cross sections, the long sections, and the works. And I dare say if you did get all that, tell them to do that a road safety audit's the appropriate tool at that stage. It's beyond what I feel a safe system assessment is adding the best value. But this is great level of design detail for a safe system assessment, because you can see the intersection form, you can see some of the characteristics, which is really helpful. So their option is a roundabout, or this modified T signalized intersection, or this T intersection signalization. So they're the options that they put down. And the first thing you do always in a safe system assessment is that existing conditions. You set a baseline score, you set a baseline set of risks. That's where things are at the moment. Then you look at this design, you get your score and you filled it all out. Then you get your design. You copy the safe system assessment matrix for the existing conditions, and you modify it for the design that you've been given. So you've got this, here's the existing conditions, and now they're planning a roundabout. And I'm looking at the roundabout and I assume they're going to build it exactly as designed. And I just put this little symbol up here so it's easy for the reader to recognize what this matrix is referring to, the matrix is referring to. And then you'll see there that things get crossed out or things get added, and we add them in red so they stand out, or cross them out. And that means when they've built this roundabout, either that thing has, that factor has been removed, or this new factor has been added. And the new factor could be something that increases the likelihood of crashes or decreases the likelihood of crashes. And you go through and you make all these alterations through each of these, thinking about how does it now actually play out? And you alter the scores accordingly. And the convention is to highlight any changes in red. So you can see some of those scores changed, and some didn't. And you do this then again for each option, all the changes, all the alterations, and each is going to change things in a different way, present new risks, or going to minimize or remove other risks. So you dot point all of those in. Now, the little trick or tip here is if you've been given these designs, which are fairly high level, and you need to make some assumptions, okay? So take this one, for example. We've got a right turn at a signalized intersection here. Now, the question to be asked is, I don't have any signal phasing diagrams. Is it going to be a fully controlled right turn, a red arrow? Now, you can ask the project team that. If you do, and they say, oh, yeah, it's going to be fully controlled, you document that very clearly as a something that you have assessed this under. But if they go, oh, well, we're not sure about that yet, we'll work that out into the detailed design. Assume the worst. Always assume the worst, because the reason for that is, and this is just one that is played out in practice, is that if you assume that is fully controlled and that factors into your scoring, and they make decisions, based on that, and then it actually gets built, and then it's not fully controlled. It hasn't been chosen on that, a correct merit in terms of the scoring, at least for the safe system aspect of decisions around these projects. So assume the worst. It actually helps the project team often, because your recommendation might be that this is a fully controlled right turn, and they can accept that recommendation once they've gone through their process. And then it shows that they've got a commitment to getting the best out of it, the safe systems assessments adding value, and that they're taking these things on. Assume the worst is always the good way to go. So you go through, you score all those different ones, and then you get that end result. The end result, and you can say the existing conditions we saw are 118.5. Design option, well, in this case, it looks like they had a lot of design options originally. They knocked out a few. They said, do the safe system on these 3, which were 2, 3A, and 3B. Okay, that's fine. Roundabout comes out at a score of 90. The signalized modified T, 99, and the standard T at 105. So the things that tells me immediately is everything that every one of these options has better alignment with safe system principles than the existing conditions. Now, I don't think we need to go through that big process to say that, but it does help. We know there that the roundabout is the best alignment with safe system principles for this scenario, but it's still got a score of 90. So there's still some things that could be done to get better alignment with safe system principles. And you might want to present that any way you want. Little graph like that is good for these overarching figures. And then we're back to this, and you can now see hopefully more clearly how it's played out. And then you're getting into recommending alterations. I like this because it immediately tells me, if I've gone, well, the roundabout's the best score, and we think that, from our other factors, that's good because we want to use the roundabout, but I'm worried about that. And is there any way we could maybe pull this one down as well? We're looking good on these ones, so that's pretty good. And I wonder, is there anything that could be done for motorcycles? But, you can start to see how that they can alter things, and you as an assessor can help them along that way. And that's because you provide these recommendations. And in fact, in a safe system assessment, and you'll see in the template that we're going to give you, they don't actually even call them recommendations. They call them ideas for consideration, which is a nice friendly way to say to the project team, here's a few ideas to get better alignment with safe system principles. We know you've got an incredibly complex infrastructure project on the go, and you've got cultural heritage issues, environmental issues, you've got the community going berserk for one reason or another, and you've got all of these things. But we're all committed to trying to get the best alignment with safe system principles, and here's some things you can consider doing. And what you do to even help further is to categorize those into primary safe system treatments or supporting safe system treatments. Primary is not your number one recommendation necessarily. It is, you could have multiple primary treatments, because primary treatments are anything in the road planning, design, management considerations that virtually eliminate the potential for fatal and serious injury for that crash category, for that column that you're worried about or you're analysing, for that foreseeable crash. And you can have multiple primary treatments for a crash type. Supporting any of these road planning, design, management considerations that improve the overall level of safety for any foreseeable crash type, but are not expected to virtually eliminate it. And these are all those things that, a whole lot of things that we've done a lot of in road safety in the past, and we know work, but they don't give us, that virtual elimination of crashes. So those are things like signage changes, line marking changes, curb outstands, all great stuff, really good road safety features. But we know if the speed through the intersection is high, even if we've done all of that, the mistakes are still going to happen. The energy is just too high. So the primary ones tend to be things like passenger vehicle intersection roundabouts, passenger vehicle runoff road, flexible safety barrier continuous, or at that isolated location that you're particularly concerned about. Things that bring the speeds down within those tolerable levels, be that local area traffic management, raised pedestrian crossings that you are sure those speeds are going to be down. You'll see here that there's this little other dot point in supporting. It doesn't change the ability for a primary treatment to be implemented in the future. So in some situations, if it was to be like a set of traffic signals being put in on an 80 km/h road, where it's a give-way sign currently. Their plan is to put a set of traffic signals there. You would actually probably say that this goes down into our category of non-safe system. So you wouldn't be recommending that, but what you would be doing is using that in your vocabulary. You know, say the current signalization is a non-safe system treatment because it reduces the ability for us to put a roundabout in the future or have measures that will get us to the virtual elimination. They're few and far between we talk in that language, and really we're just saying to the project team, here's a whole lot of things that you could do to get better aligned with safe system principles. Some of them are the best ones, the primary ones, and the others are supporting. Now they may say, yep, great, we're going to do this primary one and we're going to do these 3 supporting ones. And that's great. And then, as we talked about before, you may then decide, or they may then decide to ask you to do that final assessment to show how wonderful their final product is. These 2, I dare say, are going to be one of the things that are going to be a challenge for people to get their head around. And to aid you in that, the Austroads Safe System Assessment Framework has pages of treatments categorized by primary or supporting. So that should help you. So you can actually go to that on page, I think it's 27 of the Safe System Assessment Framework. It starts there and it says, for runoff road crashes, here are some primary treatments, here are some supporting treatments. So you might be thinking of, installing, suggesting the installation of sealed shoulders, or adding sealed shoulders to this project, and you go, well, that's going to be a really great thing for road safety, and you could look it up in that Austroads guide, and you discover, well, it is a good thing for road safety, but it's a supporting treatment. We know that even those sealed shoulders are not going to virtually eliminate death and serious injury; they will reduce it. And in a full safe system assessment, and I'll talk to you next module about full safe system assessments and rapid safe system assessments, but a full safe system assessment then really goes into these other pillars or elements of the safe system and to ask these qualitative questions. So you don't score these, you simply write your answers under each one. And the questions here are road users likely to be alert and compliant, and are there factors that might influence this? What are the expected compliance and enforcement levels for alcohol, drugs, road rules, driving hours? What is the likelihood of driver fatigue? So are we, in the middle of nowhere, and can enforcement be conducted safely? Are there special road users? Is it an entertainment precinct, elderly, children, on-road activities? Distraction by environmental factors, some big, tourism thing that's there. Any risk-taking behaviour, particular risk-taking behaviour that you're aware of. So you're going to put notes under each of these for anything that you're aware of, or if you've talked to the Highway Patrol, you might get some good insights into some of this. These may influence your score in the matrix and the likelihood of crashes, or the severity of crashes even, or they may not. But they may prompt some other thought of a treatment or something that, or some alterations that could be done, not necessarily just to the infrastructure, but also to other things, other behavioural change initiatives or the like. So some examples in this space, the enforcement one certainly, in safe system assessments, and we've been able to say, well, we're putting this continuous barrier system down. I wonder how they're going to go in terms of their speed cameras and maybe the booze bus. I wonder how that would, where they want to do that, and number plate recognition vehicle. I wonder how they're going to park and where they're going to park that. And so had some great success on these big multi-million or $100 million plus projects, and some of the $50 million plus projects and the like, in terms of the capital works, where we've talked to the Highway Patrol of the area, the police, and said, this is the plan: big upgrade, duplication, continuous barrier systems. are you going to be able to do enforcement activities? And they say, oh, well, actually, no, we can't do this for this reason. And, you know, and then we say, well, you know, what would you need? And they go, oh, well, we need an area where we could, you know, safely be away from traffic, and we need this and that. And, you know, in these massive projects, those things aren't that hard to incorporate if they're identified and planned for. And so some of them we've been able to utilize sort of old stack sites for booze bus areas and areas, you know, further up the road where the number plate recognition vehicle can easily sit in the sort of maintenance gap of the system nicely, and the number plate recognition, and then down the road they are able to flag vehicles in to a fully protected area where they can, you know, drug test them, alcohol test them, and the like. And it's all built into the infrastructure rather than them trying to, you know, fit this somehow around the area, the construction that we've built, or they just abandon that whole area altogether. It just goes too hard. So we can, you know, have these purpose-built facilities, which is a wonderful outcome. In the vehicle sense, what level of alignment is there with the ideals of safer vehicles? Now, that one's really a whole of community assessment question. So that one, for most of our infrastructure projects, we're putting, well, you know, nothing of note, because, you know, it's really analysing the fleet and what's going, you know, what are the safety features in the vehicles that are in this community or in this area. So remember, because of the broad nature, sorry, not the broad nature, like the flexibility and the scope of a safe system assessment, it has to have some of these questions. What are the factors that might attract a large number of unsafe vehicles? Are there any of those there? Percentage of heavy vehicles for the road design, is that right? Recreational motorcyclists, resources to detect non-roadworthy, overloaded, unregistered vehicles and remove them from the network. And then again, can enforcement of vehicle features be conducted safely? So roadworthy checks and those sorts of things, if heavy vehicle weight testing and those sorts of things. Has vehicle breakdown been catered for? Another one that's important there. This is sort of the question where you might ask a bit about like roads that cars can read. Is there anything that being planned that a vehicle of the future may struggle to navigate when there's no driver or something like that? But we're still in the infancies of trying to get our head around that from a road design, traffic operation management perspective. We've got some ideas, and there's some European reports and information out about that, but some pretty simple things at the moment. I mean, if it's non-standard signage being used, or if you've got, you know, blacked out line marking or these sorts of things, the lane keeping recognition and those sort of things sort of switch off. But yeah, not too much of this space in just run-of-the-mill safe system assessments. Post-crash care then we get into. Okay, other issues that might influence safe and efficient post-crash care in the event of a severe injury. Now, you know, congestion, access, stopping space, probably really a motorway question. You know, if there's a crash on the freeway, how would the ambulance get there? You know, do we need lanes provided? Do we need the brakes in the continuous concrete barrier in the median so we can do contraflow and the like? Do emergency and medical services operate as efficiently and rapidly as possible? So that's one way you're starting to think now, okay, crashes happen, severe injury, how quickly can we get these people to, how quickly can medical attention get here? You know, where's the nearest hospital? How do they get these things? So that's sort of had some different ones where we've built, or they've built helicopter landing pads in the sort of mountains of New Zealand for injured motorcyclists as a result of sort of these broad safe system assessments that were happening a while back as part of a coordinated strategy and effort there. Due to that, so this question really that said, you know, how quickly is this all happening? And it was a long time to get up there to extract these injured riders, and the helicopters was very struggling to find appropriate places. Are the road users and emergency response teams protected during the event of a crash? Are drivers given the correct information on travel speed's approach to the incident? Is there available information via radio and VMS? Is there provision for e-safety, safety system based on modern information, communication technology, cooperative ITS and the like? Again, that question, a bit more of a community managing a fleet style question. So you're not really going to have any answers as you do an infrastructure project on some of these. And that's okay. The idea behind these is that you think about this. You think broader than just the pouring of concrete and the installation of a barrier system or or the like. You're thinking holistically about the system because it is a system, and we need to think about all these elements or all these pillars to get our outcomes. You dot point things under each of these ideas, things that you're considering, and then if you have any recommendations or things that could be changed, you put that in. And it could be anything. It could be that you go, well, there's a school around the corner, and the kids are going to use this this new facility that's been built. Could we do some education and some education sessions with the students on how to use the new facility best? This could be something like that. It could be there's a pub and you say, well, what's that pub doing in terms of trying to manage intoxicated pedestrians coming out of there, or even to the point of pubs where managing intoxicated drivers leaving that area. It's well beyond what we usually do in an infrastructure project, but this gives us the facility to acknowledge that holistic system that we're dealing with and see if we can inject anything in there. I'll pause there and see if there's any questions at this stage.
Thank you, Ken. Earlier you gave the example, and this might be an opportunity to reiterate exactly when to do a safe system assessment. The examples given in the slides refer to the planning and design process of a project. How do we apply a safe system assessment on an existing location where a crash has occurred, or is that a time you undertake a road safety audit? And there's an example here where they've received a recent report that a learner driver lost control and hit fencing on a nearby childcare centre. No history of reported crashes at the location in the last 5 years. Police have suggested to the childcare management to install bollards in the nature strip. So is that RSA or SSA?
Well, you do have some options there. I mean, incident investigation, crash investigation is potentially what you actually want to be doing in that sense, because there has been a specific incident. You can start sort of analyze that to a degree. But if you're taking a step back from that and holistically looking at this area and just trying to get a calibration on the risk, a safe system assessment might be a good one, because you are thinking about that broad context of it. In terms of, you won't just stop at the infrastructure in play. You'll be looking further and wider about safety issues around the area. The only thing that I suppose I'm a little bit cautious of is that there's a very specific thing that is being looked at there, rather than the holistic system nature. So you might find yourselves in a more elaborate exercise with the safe system assessment framework than you want. But nonetheless, because you're going to be forced to look at pedestrians, cyclists, motorcyclists, run-off road, intersection crashes, and all of these factors combined, and going through that matrix. So if you don't have a design as such, but this one, it kind of does sound like there is something, even though it's so planning idea stage, but there's something planned with bollards. But you would do just your existing conditions, and you could do just existing conditions in a safe system assessment. You just go, that's what it is, and here are some recommendations to bring that score down. And you could leave it at that. theoretically, if you did want to do some hypotheticals on, okay, if you chose this option or this option, these are where your scores could get to, that could be done in that case. Or you could say, right, you're going to include bollards, that changes the score by this or this. And you might actually see that runoff road increases, so the dangers to the occupants of vehicles increase, depending on the speed zone and those sorts of things. Pedestrians might come down a bit, but you're moving risk around the crash types and the road users. And it could help to paint a picture from that perspective. So it could be an option there. A road safety audit could also be a good option in terms of it will do similar things, look at similar things. Depending on your jurisdiction, it will also come up with recommendations, and it will risk rate things as well, high, medium, low, intolerable, and the like. So it could be a good one there. But I suppose the safe system assessment in a full context will give you analysis then of what is the operation of that childcare centre, or how are they doing their drop-offs, pickups, what sort of things are they doing with the any education in there, what are the vehicles travelling through. So it'll be a bigger exercise, I dare say, with a safe system assessment, but it could be quite a nice, rich outcome. The other thing that I haven't really mentioned, and I do mention this more next module as well, is that there is unbelievable power to numbers. Now, this is one thing a road safety audit doesn't do. I mean, it does it with the risk assessment, and you get high, medium, low, and that's good, and that's very helpful. But when people see these graphs, they really, their head gets into this space of rigorous analysis and numbers and quantification and it's almost the combating to a SIDRA report or a traffic modelling report with juicy data, and you've seen that there's a bit of subjectivity to this, but there's a bit of science to it as well. So that's something pretty good. We know that traffic modelling has a bit of judgment in there sometimes, and subjectivity and assumptions as well. So it starts to get us in the road safety space on that page of putting down some data and some graphs and the like, which I think is a really good thing. It's pretty rare. I mean, no, it does happen. The SIDRA report comes down and people go, oh no, I know that intersection well, and that's not an issue or the like. People are like, well, no, the traffic modelling says it is, so that's the issue. But I think lots of you have worked in the road safety space, and you sometimes put down your audit report and it gets challenged. Like, oh no, I know that intersection, never seen a crash in that. No, never seen that crash or even an incident like that. No, you don't understand the intersection, you don't understand the area, and you're like, well, I suppose it's a little bit of the everybody's an expert in road safety because they're a road user in their mind, and they're a driver. And I'm sure a lot of you working in the space have had that one many times in your career, where the person starts with, I've been driving for 50 years, and you go, okay, well, that's your personal experience. It's not going to be a result of understanding large studies and statistically significant results on things and research and analysis. It's an individual opinion based on some very specific factors. Yet, because it's theirs and their experiences, they are so confident on these specific elements. So the addition of this ability to graph this and quantify things is a pretty powerful tool. And that's a really helpful thing in us navigating some projects and some road safety benefits through. I'll talk to you next module about some of the unfortunate consequences of us putting numbers to things, and certain projects gaming the system and trying to, weasel through numbers and the like. But that's the next module, an exciting little insight. The other beauty of numbers, and I should really mention this, sorry, Kathy, I know somebody else has got a question, is that if you put a 0 in any place in a crash type, multiply anything by 0, it comes out as a 0, doesn't it? And that is logical because, let me talk this through. Let's take intersections, for example. If there are no, like this is a mid-block section, there are no intersections, you put a 0 there, the likelihood of crash does not matter. The severity of crash does not matter. There is no exposure to crashes. There is no intersection. Likewise, if you are absolutely hand on heart able to say that there is 0 likelihood of crashes, which, little note here, you wouldn't be able to say because we've got humans and they fail and there's probably going to be crashes. But theoretically, if you could put a 0 there, you don't care how many are exposed to the crash or what the severity of the crash is because no crashes are going to happen. And if you can put a 0 in severity, and I'm going to put a little disclaimer on this one. If you could put a 0 in severity, meaning that when all these crashes happen, it is not going to result in death or serious injury because it's well within these tolerances of biomechanical injury levels. You don't actually care what the exposure to crashes is or the likelihood of crashes because the end result is no death or serious injury for our community under every one of these incidents. The little disclaimer there, though, is for if you happen to get a 4, 4, and a 0, yes, your safe system output is a 0. It's great. However, you're probably going to get a whole lot of minor bingles happening in this location. And that's probably something worth addressing in the project from a sort of traffic engineering perspective and the like, because you're going to have a whole lot of like fender benders or the like going on there. But, in pure safe system thinking, we're okay with crashes happening as long as they don't result in death or serious injury. Obviously, we want to try to minimize any of these disruptions to the network. Now, Kathy, I'll take that question or comment you wanted to jump.
Thank you, Ken. I might need some extra information on this one, or you might. Just confirming that primary support and non-safe treatments are outside the design that you are assessing.
Yeah, so that's associated with the recommendations. So it's really categorizing anything that you recommend, any alterations you're recommending. So, if they've got, like, you may use that as terminology if you want about what they're planning with their designs and the like. But really, you're going to say something like, we recommend continuous flexible barrier system for this length of road on the roadside, and that is and then you categorize that as primary for run-off road crashes or passenger. So it is really all about the recommendations, the new things, the changes, the alterations of the design that are being planned for. You don't get their design and categorize it as such. You just help them by saying, here are ideas for you to consider, and here are the ones that are primary, and here are the ones that are supporting. Okay, so the report format.
We're okay.
That's it? Sorry, Kathy?
Yep, okay for questions, sorry.
Yeah, no, that's okay. The report format. So generally a report should include, now road safety auditors out there are going to be pretty happy with this, I think, because it's generally been modeled on a road safety audit report to make life a little bit easier. And in fact, the process that we go through, which is part of the next module, is pretty much the same as a road safety audit sort of process, from engagement with client and going through and inspecting site and reporting and those sorts of things. But you put in there the type of treatment you're doing, a full or a rapid. And again, I'll talk to you about the difference between those next module. For your assignment, you're doing a rapid one. and a modified rapid one at that. You list your team, just like you would in an audit report. You list any inspections and meetings that you've done, just like a road safety audit report. You sort of describe the process, and that's important so people who are unfamiliar with this get an idea of what's happened. You pop in some project background and the context of the project, which you've gathered from those questions that you asked early on, and you've got all that information. You pop that in, and you maybe reference the designs that you've looked at. Then you fill out that matrix, and you make all the commentary on factors that increase or decrease the scores for the existing conditions, and then all the design options you've got. And if you've chopped up your design into multiple sections, you do multiple matrices. Commentary on the other elements of the SAFE system and how so that's your qualitative commentary through those questions we just went through. And then you do your suggested treatments or changes, the proposed design that would improve alignment with SAFE system principles, and you mark each of those as either primary or supporting. Remind me to come back to how you would chop up a project. We do have a fact sheet specifically on that to help you when you get to those long projects that have multiple intersections and different parts, and it's very challenging. What your task is going to be is that we've provided you with a design in your local area. And what you're going to do is utilize the wonderful template that we've provided you, and it's a Word document template. And it's actually the Victorian Government's Safe System Assessment template. You are going to go through it, and all you need to do is change anything that is highlighted yellow. So we really tried to make your life easy for this. If you were doing this in the real world, so out there doing a safe system assessment, you'd want to fill out everything in the whole report, but we've crossed out a whole lot of stuff because we don't want you to be spending many hours writing project backgrounds and all these, different elements. We just want to know that you can go through the filling out of the matrix and recommendations and categorizing things. We do want you to do a brief summary of your assessment after you've finished it. So we've got that summary there, and we want you to create your own graph in Excel or other graphing softwares and paste that in and fill out the scores that you get for your existing conditions and your design. You can see that you get a matrix like that. You're going to fill it out for the existing conditions first, then you're going to copy it, you're going to paste it, and you're going to change it for the design that you've got. I'll jump into the actual Word document to show you that in a bit more detail in a second, but I just want to have a little chat about the site safety when you go out there to do your site inspection. We do require you to do a site inspection of some form. Now, the reason for this is a little bit like a road safety audit. You gather a wonderful understanding of how the area is operating, the road users, what's really going on out there. And you see often things that you just can't see from street view or from the like. So you need to get a feel for that site. And we want that because that is good practice in these safe system assessments to do that. For the purposes of our training, though, we don't need you to be out there a huge amount of time. We certainly don't need you doing detailed things like measuring lane widths or putting your head down to look at the crossfall of the drainage and those sorts of things. And we really just stress this needs to be done safely. We've assessed all the sites and they can be done safely in one way or another, as long as you have common sense about it. Wear your high-vis vest, stay off the road unless you're crossing. Don't be a hazard to other road users, so don't congregate and make people walk onto the road. Park safely, don't park in areas that are going to obstruct people's sight lines or, again, make bicyclists ride into traffic or the like. Park on some side streets or away from them, these sort of things. And we have a safe work method statement which we've provided, and you're going to have to, as a quiz question, acknowledge that you will operate under that, and it'll be very much the same as your organizational ones, which I'm sure you will be operating under. But you're going to, essentially acknowledge you're not going to be intoxicated while you're out there, and you're going to wear your vest, and you're going to do all these appropriate safe things. So that's the little safety briefing. We do want you to take a photo of yourself on site so that we know you did go to site to meet our educational assurance requirements, that you've you've done all the things that we're asking. Okay, so Kathy, tell me if there's any new questions that have popped up, but I'm just going to jump into the Word document with the template and just show everybody all the things to cover.
Just a quick question on what level of responsibility do we have as engineers who've recommended specific treatments or recommendations in the event of a fatal collision?
So as a safe system assessor, it's your, I suppose, responsibilities end when you've handed over your report in the sense of whether or not they take on your recommendations or not. I mean, that is not our role as safe system assessors. We are providing advice in the package of a document, and the project team needs to take that on. Now, if we've recommended something and they have not taken it on for one reason or another, that might come back to them down the track as to, well, this safe system assessor has recommended these alterations and you didn't take them on. Why didn't you take them on? And they would want to be documenting some good reasoning why they didn't take this on, and probably how they've managed risk in another way if they're not taking that on. In terms of some sort of legal liability for us as the assessors as such, it would be more in terms of the process we've gone through as to whether there's any risk for us in a liability sense. And certainly if you didn't follow the correct processes, if you were unqualified in undertaking a safe system assessment or the like, that may be a way, a bit like road safety auditing as well. I mean, if you are to falsify and say I'm a senior road safety auditor or a level 3 auditor, and you actually aren't, I mean you're in you're in the firing line then in a legal liability sense, and you're held to account for a reasonable assessment in court, a reasonable audit, so a reasonable thing that industry would pick up or would recommend. So there's a little bit of something in there that's possible. Certainly, I've been put into different court scenarios with road safety audits more than safe system assessments, it's the road authorities that are getting hammered, and then the road authority will just try to pull you in as the into their camp of being hammered, and so you want to be very confident with the process that you've followed and the team that you've put together for your assessment and the like. These are very few and far between, these legal incidents. So I hope that sort of captures that. I can talk a little bit more about some of the legal liabilities, but I do say that I'm not a legal expert, and if you have any concerns in these spaces, you should get in your own legal advice.
There was a follow-up to it. I'm not sure if you've covered it, but what if they accept the recommendations that have been put forward?
I didn't really cover that. So yes, if they've accepted your recommendations and then an incident occurs, it may come back to you to say, well, why did you recommend that? So you do need to be fairly confident around your recommendations, and have some principles behind it in terms of reducing speed or conflict points or angles, or reducing the energy of crashes. If you're suggesting some innovative stuff, it's always good to know either where that's been trialed and results of trials and those sorts of things. So to a degree, in the recommendation space, you might need to be ensuring that you are in a team with some people who play in the infrastructure road safety space a fair bit and have some understanding of that. The actual assessment itself is really that clear-cut. This is what my opinion is on that. Recommendations is a funny one, and I did mention this, I think, earlier about New South Wales not wanting recommendations in road safety audit reports for, well, as far as I can boil it down to, for legal reasons. I'm sure some of the New South Wales people, Wade or somebody, will be able to clarify that much further than I can. But the worry of these legal liability issues popping up if road authorities don't take on the recommendations, or do take on the recommendations and then incidents happen and the like. I think the reality is the road safety auditors are the best place to recommend alterations to infrastructure that will reduce harm, because that is the space that we're playing in our whole life. Whereas the project manager of an infrastructure project has so many other things, and their expertise may be in, I don't know, concrete, or maybe in project management or these sort of things. They're not spending their life in the road safety infrastructure space. So both the road safety audit and a safe system assessment, I believe the assessors are best placed to help and provide that guidance. And then these sort of fears of these sorts of issues down the track, I don't think warrant us sort of ignoring that. And there's a few mechanisms in place. But as I said, I think with the new Austra's Guide to Road Safety Part 6, which hopefully will be coming out early next year, I think there's a bit more clarity around that. And I dare say the only jurisdiction not to put recommendations in, New South Wales, will be probably reverting to recommendations. So here is the report that you'll be using. As I said, I've just used the Victorian Government template for safe system assessments. On the Victorian Government website, the VicRoads website, it actually says, please feel free to take this, to rebrand it. You know, put your own brand on there. This is not like where they're keeping copyright or anything like that. They want you to use it. They want industry consistency. It's great. So, you know, rebrand it if you want, if you're going to use it for future ones. For your assignment, don't waste time doing any of that. Just fill out the highlighted bits, only the highlighted bits. We're trying to save you lots of time here. So we don't even want an executive summary, table of contents, update, or anything like that. We're just straight into the, we just want to go straight into the, put your name in. Now, if you do this as a team, which we're happy for you to work as a team if you get the same site and you know that, or you're in the same office or the like. So put the name of all your team members in there so we know who is involved. We don't want that background, context, all of that stuff. We're not being provided with it. It's not going to help you do your assessment in a this rigorous way. But for the training exercise, that's okay. We just want you to show us that filling out of the matrix and those sorts of things. Do put a short description of the proposed works. You might even want to put a snippet of the design in there, and just to show this is what's being planned and this is what we've done the assessment on. You do the summary of your assessment. You'd fill out these words after you've actually done the assessment and the numbers and the graph, because you're going to need to do this matrix first. And there we've shown it. You write in these, you put in the scores, you put in your factors that increase the likelihood, decrease the likelihood, factors that increase the severity, decrease the severity, put your scores in. Once you're happy with all of that, copy it, paste it, alter it, change the color of the text, and then you fill out these two tables: primary treatments, supporting treatments, treatments for consideration, things that the project should consider adding or altering in their project. You do not fill out the project's response. This is left blank in a safe system assessment, because when you hand it over to that project team, the designer and the project manager, this is the reminder for them to do something. And if they don't want to do one of these primary treatments, they need to write in there why they can't do that, or they don't want to do it, or instead they're doing the next one down, which they believe is the more appropriate one with their project constraints or whatever it is. That's their reminder. Here's the report. You got to do something with it. And then you, in a proper safe system assessment, you'd put your site photos and those sorts of things in the appendix. For this one, add a photo of you at the site. So prove to us that you've met that requirement of going and having a look at the site and getting a feel for how it operates, and the road users there, and those little bits and pieces you just can't see from Street View. Okay, last couple of minutes, and I'll take any questions on your task. So you'll complete that, and then you will upload it to Schoology, and it will be marked. Now, it's good if you can PDF it and then upload it. Just helps us to read it in the system, but if not, that's okay. Just upload it as a Word document. If you have trouble with it in Schoology and you can't for some reason upload it, email it through to Kathy, email it through to Kathy. If you're struggling, if you get your design out of Schoology, and maybe Kathy will show where your designs are housed. You get this design and you go about doing, looking at it and trying to understand the template you've got, and you just really can't get your head around it. Don't get too down and don't waste a lot of time. Just get on the phone, call me, send an email. We'll organize a one-on-one. I'll coach you through it, and we'll make sure you can do that quite easily. So the question here is, in real life, do we have to be a team of 2 as a minimum, like road safety auditing? Do we have to, and do we have to have senior members in the team, or can both members be the same level? Of course, it is preferred to have a senior. It's a good question. There is not that much clarity around these days, and I'll cover this a bit more in module 6, so the next module, after you've done your assessment. Victoria's sort of moved along in terms of providing a list of recommended safe system assessors that have proven capability in these areas. I think Queensland's going to move down that track as well. There is nothing documented anywhere, though, really, to say, you must have, this amount of experience or these sorts of things to be part of a team. And it's not really specified anywhere that it should be a team. It is in the Victorian guidance sort of said that a team is highly preferable, but I think it still gives you the ability that technically you could do a one-person safe system assessment, and that might be appropriate in some circumstances, but it does encourage you down the line of a team. And I think, like a road safety audit, teams are wonderful to bounce ideas off, different lenses on issues, different backgrounds and experiences, gives you a richer assessment. But we understand that sometimes that may not be able to happen. Now, Kathy, I'm going to read what Wade's popped in. Do you want to show where they can find some different stuff?
Yes, I do. So basically what you've got here is in module 5, which has appeared in Schoology, complete your safe system assessment. There's that safe work method statement and agreement in there. So there's the document and just the quiz question for you to complete in there. Your safe system assessment is here. So there's that template that Ken took you through earlier. Now, what you should have over here is a submit button. So it doesn't quite look like that on my screen, but you have a submit. So if you submit your completed report here as a PDF, that'll be great. Your sites are in the next folder down, and so they are located by your name, basically. So some of you will have the same site if you're not too far away from each other, and so there it is there. And basically what you can do from here is download it. And just a reminder that they might be real sites, but they are just used for training purposes on this occasion, and we'll have traffic counts on there for you as well to help you with the exposure side of things. So if there's any questions on that.
So just to reiterate a point there that Kathy's made, some of these are real, some are designs that have been produced by our designers in-house for training purposes. But regardless, do not talk to the public about the design. If somebody comes up to you, as they love to do when you're wearing a high-vis vest, and ask what you're doing and the like, just say, I'm out for a training exercise. If you are the designer or a part of the project team for the one that's been provided, that's okay. We still want you to go through the exercise, even if it's your own design. So that's not a problem. And Wade's provided some wonderful commentary around the challenges of recommendations in New South Wales and the risks associated with that, and then the assurance implications of making recommendations, not making recommendations, and there's a huge amount in there. So suggest, if you're pondering things in that space, have a chat with Wade or myself. I can put you in contact, and really rich, interesting topic there. So I think that's probably about everything, isn't it there, Kathy? Any questions from anybody? You've got an exciting thing to do now, really into the practical stuff. We want you to start assessing, and I'm sure you're going to do a wonderful job of it.
Sure. Just a reminder too that you don't get away without a quiz this session. So your module 4 quiz after today's session is there for you. Look, we've made it due early, not next week, the week after. So looking at the following Monday would be great. Ideally, we'd like you to get out and do your visit, all except for people in South Australia, in the next week or so, while it's all still fresh, and get it into us early the week after. So our next session together is next Thursday. And then if you take the weekend or so to complete it after that. You have all been given sites near your place. We've calculated the longest drive at 22 minutes, so hopefully that's accurate and with traffic. But there was a question here about, there's an existing roundabout proposed to be replaced with traffic signals. How do I go about in terms of primary or supporting treatments? Do I refer to the proposed design and pick the relevant elements?
No. So you don't worry about what's being proposed in the design. That's that doesn't get categorized. What you're doing is you're looking at that design of the traffic signals, if the roundabouts are removed and traffic signals are going in. And then when you say, right, if you want to do traffic signals, which you're doing, here are some recommendations. And you might say, well, I recommend you do raised safety platforms on the approach to the intersection, which reduce vehicle speeds to 50 kilometers per hour, which is a primary treatment for intersection crashes for passenger vehicles. Or you say, well, I've looked at the design and I think it should, there's going to be insufficient sight distance to the signals, so or the back of queue, so it should be active advanced warning signs on the approach around the curve, and that is a supporting treatment. So forget about primary or supporting for the actual design you've got. It's all about your recommendations or your ideas for consideration.
Is there any issues if the person's been involved in the design project for the site?
So for this training exercise, that's fine. Doesn't matter even if you're the designer. Now, you know, there's more flexibility in a safe system assessment than a road safety audit in terms of conflict, in terms of involvement with it, but still we usually get the leader of the safe system assessment to be independent completely. But for the purposes of training, the process still is all valid. So you can just run through that.
Great. Now, what we might do, there are a couple of people with the same site, so I will get in touch with both of you, and if you'd like to complete it together, you can do that. And we might also just keep our New South Wales guests on the line for a little bit longer, because we don't have a site for them, and we were just going to talk through that together. If you guys have a couple of minutes now, that'll be great.
Oh, okay.
Is that okay with you, Ken?
It's the bypass one.
Yes, the bypass one. If they've got a couple of minutes as well now.
Yeah.
Other than that, as Ken said, if there's any questions, anything at all, please do email, call, anything over the next week, and we'll be sure to help you out.
Okay.
Is that right, Ken?
Yeah, that's good. I was going to call. Hopefully there. Oh yeah, well, yeah. Good. Thanks, Joe. Yeah.
No worries. Tracy, no, you're good. You've got a site, so you can go. I'll stop the recording, and basically